What's up, this is Christian, and today we're going to be solving this problem right here. It's valid parentheses. So essentially what's happening is we're going to receive pairs of parentheses, open and close. We're going to receive pairs of square brackets and pairs of curly brackets as well. We want to make sure that every open bracket or open parentheses has a closed pair that goes along with it, but it has to be in the correct order. So what we're going to be using is the data structure stack. So we're going to be creating a stack of all the open instances of the brackets or braces or whatever we may be working with, and we're going to be pairing it up with the closed pair. So if at the top of the stack we have an open parenthesis, we need to make sure that the next value we look at that's a closed is a closed parenthesis. I'm going to show you a couple of examples. So here's our first example, simple one. We have an open parenthesis, and then following that we have a closed parenthesis. So the stack will always have one open parenthesis, and then it'll pop out once that closed parenthesis is paired. And the way we're going to be checking to make sure that it's a matching pair is we're going to be using lists, and I shall use a second example where I actually use the dictionary to test this. So then here we have another example of a pair that does not match. So as you can see, we have an open parenthesis, but then we have a closed square bracket. So in that case, it's automatically false. So if we have more examples, if we have more pairs after that, the whole thing is just going to be false. So finally, this last one is going to be an example of true that kind of like iterates what I was talking about. So we have an open curly bracket and we have a open curly bracket and an open square bracket, right? So following that, we have to have a closed square bracket because at the top of the stack that we're keeping, we have that open square bracket, right? So then we pop that out, and then once we get that curly bracket, then we'll match it with that open curly bracket as well, and the final solution will be true. So we go over a couple of examples here, and I give you two different implementation. So hope you enjoy the video. We're on this programming journey together. I'm still learning, you're still learning, so it's all good. Let me know if you have any questions, and enjoy. The best way I can think of doing this is to create a list of the open brackets and then the closed brackets. So we'll do opened, and then we'll do like a list like this. Yeah, let's go. So do this, and then this, and then this. Okay, so then the opposite will be true for closed. Close parentheses, close bracket, and then closed curly bracket. And we want to make sure that they're in the same order just because of the implementation that I have in mind. So I don't know why that's turning blue. I guess that's some sort of command that's already reserved, some sort of keyword that's reserved. So we'll create an empty stack. Should I push the first element into here? Should I initialize it with the first element? I don't think so actually, because if we push one of these into there, then it might complicate the solution I have. Okay, so then we're going to iterate through the string for C, which will stand for char, and S. If C is or in opened, then we'll do stack.append C. So we're going to keep track of these open ones because we're looking for these pairs, right? And then elif C enclosed, if the length of the stack is equal to 0, then we'll return false automatically, meaning that there's not a pair for one of these close parentheses. And then, so if that doesn't happen, then we'll keep track of the popped value. Pop equals stack.pop. So we're going to pop the last value in there. So we'll pop that out, and then if, so this is why I wanted these in the same order, because we're going to track the index of this and compare it to the index of this, right? So the pop value should be one of these, correct? So if, let's see how it is, if opened dot index of pop, so this will give us either 0, 1, 2, doesn't equal to the current value of C, so that'll be close dot index of C. If that is not true, then we return false. And if not, then we just continue, right? So at the end, if we make it through everything, we return true. But we do want to check to make sure that the stack is empty. So if the length of the stack is equal to 0, or it doesn't equal 0, sorry, then we'll return false. Okay, so let's do a quick trace for this problem. Make sure we're on the right track. So do it like this. We'll do one of these, get that, and then we'll keep track of the stack. Okay, we'll do it like that. Okay, so we have the stack C, then we'll append this curly bracket. Okay. Oh my gosh. We append this curly bracket into there, right? Okay. And then we're going to get another close bracket here. So we'll get one of these. Boom. So this is our stack for right now, right? Because we're just appending these. C is not enclosed, and we're doing this if statement, so we'll keep going. So now we finally get to our first close bracket. So this is not going to be true, so we're going to go here. If C enclosed, if the length of the stack is equal to 0, we'll return false, which is not true. It should be equal to 2. Then we'll pop this value, right? So we're popping this, and then we're getting the index of that, which should be equal to 1. And if it doesn't equal to the close index of this value here, which should also be 1, then we'll return false. If not, we just keep going. And so that'll come out of the stack, and then we'll be looking at this value versus this curly bracket. So we'll see that the length of the stack isn't equal to 0. We'll pop out this value, and then we'll check the index. So if open.index of the popped, which is this, it should be equal to 2, the number 2, sorry. And then if it doesn't equal to the closing index, which should be also equal to 2, then we'll return false. If not, we'll keep going for C and S. So this will be the end of S. So we'll check to make sure that the stack is empty, and if it is, then we'll just return true. So that looks pretty good. So we'll run that. Okay, looking good. We'll add the rest of the test cases. Run it again. Sorry. Okay, it's coming out true. And then we'll submit. So if this works appropriately, looks good. Memory usage looks pretty bad. I don't know if that's accurate because that's really, really low. I'm kind of wondering what I'm doing wrong. Okay, that's just such a huge difference. I don't really know what determines these numbers, but it's very inconsistent. Okay, so I actually just thought of a second way to do this. This will be a little bit more interesting. So we can solve this using tuples as well. So I think it's tuple. We go like this, and then we can just do all the different types of brackets like that. I'll just copy this actually. So we can get it like this, and then do closed equals to a tuple of this. Okay, and then we can create a dictionary from this. So let's name it D equals to, let's see how to do this. I do dict and then zip, and I believe we go opened and then closed. So this will pair this value as a key, this value as the value, I believe. Okay, so then we're still going to be using a stack. We're still going to be iterating the same way, but instead of appending C, we're going to append just the close value. So what we'll do is we can get the position. So I equals to, let's see, I equals to, how can I do this? Closed. No, we'll do opened of C since it's a dictionary, and then we'll do append. No, actually, I could just do it like this, right? Since this is, yeah, perfect. Yeah, so we don't actually need to get the position of it. We can just put the open of C. Since these are the keys, we're looking for this specific key. So in this case, if we're looking for one of these, oh, I gotta do this in the same order. So that's parentheses, close parentheses, and then a bracket. Okay, so it's gonna, this is the key and this is the value. So if I search for this key, it's gonna return this value. So whatever we're getting, we're gonna append that to the stack, right? So now we're checking if C, let's see, how am I gonna do this? So now we're just appending the close brackets into here. So what I can do is C, I mean, we can still do a check to make sure that C is enclosed. Let's see. Yeah, so I think we can still check the C to make sure it's enclosed. And if it is, that'll be true also. And then we can do pretty much the same thing, right? We'll do opened of pop. Is that how she did it? See, we pop out that value. Okay, so keep track of that. Now, if we just do D of, would that work? No, I don't think that would work because we're popping out the value we're looking at, right? So that doesn't actually make sense. I guess the value we're popping out should actually equal the value we're looking at. So if the pop should actually equal to the character we're looking at, right? Yeah. So since we're appending just the closes, so if we get this value, we append this to the stack instead, the close bracket. So since we have the close bracket, if C is enclosed, then the first value in the stack should be equal to the close that we're looking at, right? So then we'll return false, stack is equal to this. Okay, that should work. Ooh. Oh, I misspelled tuple. Okay, so run this, should work. Stack that append, opened. Oh, okay, sorry. It's actually D of C. Yeah, since we're referring to the dictionary, so we still have all the test cases here. We'll run that again. And yeah, we got it. Okay, so those are two different implementations that you can follow to solve this problem. Worked out pretty well. If you guys have any questions, let me know, and I'll catch you on the next one.